Okay, my third floating point binary arithmetic example again is another negative number example, but it's also got a little twist in this time, so watch carefully. Let's first of all examine the mantissa. Again, we see that the sign bit is worth 1, so that's proof that it's negative, and we know by now that the most significant bit is worth -1, so I'm going to put that there. My binary point would follow, so I'll put that in there, and then that's going to be followed by the fractional values of the mantissa. So let's add those fractions in. We're going to have a 1/2, a 1/4. We're not going to have an 1/8 because there's no 1 there, but we will have 16th. And then the rest of the mantissa, which is only made up of 8 bits this time, is 0, so I don't need those values. Let's work out what that answer would give. So that's -1 plus 0.5 plus 0.25, and then finally add to that 0.0625. Okay, the final answer to all of that is minus 0.1875. Okay, let's stop that just there for a minute. Let's look at the exponent, and then let's work out this value. Now I'm just going to change my colour here because this is a trick that the exam board could throw at you to catch you out. So be wary of it. Let's write down the value of the exponent. Here we go. The exponent. My x right. 1, 1, 1, 0. Now, the thing about the exponent is it's always written in 2's complement. What does that mean? Well, it means that the most significant bit is always negative. Let's see, what is that most significant bit actually worth? Well, this would be worth 1, that would be worth a weighting of 2, this would be 4, this would normally be 8, but because it's in 2's complement, the most significant bit is negative. So we make that -8. So what have I got? Well, if I'm going to work this out, the actual answer that I'm going to get will be equal to -8, add 4, add 2, there's no 0 there, and the answer to that is going to be -2. So now I can go back to my original calculation and find out what the final answer would be. And looking at the values, I guess this is going to be quite small. Take my mantissa, minus 0.1875, multiply by 2, but this time the exponent has a value of -2. So let's multiply that out together, and we get a final answer of minus 0.046875. And that's the final answer to the question. So watch out for that in the exam. If the sign bit is a 1, then you know the answer for the mantissa is going to be negative. But then that was the most significant bit anyway. It's negative. It's in 2's complement anyway. Don't get caught out by the exponent. Look at the exponent and remember that it will always be written in 2's complement. So the most significant bit, if there's a 1 there, is going to have a negative value.